Hello students, welcome back. I'm Rinkesh sir and today we'll start with miscellaneous exercise 10 of chapter number 10, that is vector algebra. Okay, let's start with the first question. Question number 1. Write down a unit vector in xy plane making an angle 30 degree with positive direction of x-axis. Now see, as vector is in xy plane, that means z component will be equal to 0. The vector will be equal to xi plus yj. Okay, the vector will be equal to xi plus yj. Now it is making an angle 30 degree with positive direction of x-axis, and also it is a unit vector. So I can write down x square plus y square will be equal to 1. So that implies under root of x square plus y square equal to 1 because it is unit vector. X square plus y square is equal to 1. Now angle it is making 30 degree with positive x axis. So I can write it down cos 30 degree. So here let's take modulus. That will cos 30 will be equal to x upon modulus of x by 1. What is cos 30? Cos 30, its value is root 3 by 2. So this implies x equal to root 3 by 2. I got the x component. Now already it's x square plus y square equal to 1. Right? So from 1 x square, that is root 3 by 2 square, 3 by 4 plus y square is equal to 1. So y square is equal to 1 minus 3 by 4, that is 4 minus 3, 1 by 4. Y is equal to 1 by 2. Okay, so the required vector A is equal to x, that is root 3 by 2 I plus 1 by 2 j. Here, this was the first question. Now, let's see question 2. Find the scalar component of magnitude of vector joining points P, x1 y1 z1, q, x2 y2 z2. So vector PQ, that will be equal to q minus p, x2 minus x1, y2 minus y1, z2 minus z1. Clear? Now you have to find out the scalar components. So scalar components are x2 minus x, y2 minus y, z2 minus z1. And magnitude, that will be equal to under root of magnitude, that is magnitude of vector PQ under root of x square, here it's x2 minus x1 whole square, y2 minus y1 whole square, z2 minus z1. Okay, clear? Now let's see question third. This was question second. Let's see question third. Girl walks 4 kilometers towards west. West means in this direction. Okay, so let's take the first displacement A, that is equal to minus 4I. Okay, then she moves 3 kilometers in the direction 30 degree east of north and stop. Means 30 degree east of north. So that will be equal to, this is the north direction and this is 30 degree. So it makes this angle at 60 degree. So I will take theta equal to 60 degree, right? So this component, now I can write down this vector B, okay, vector B as, now what is that? Is magnitude? It's 3 kilometer, right? So 3 sine 60 degree. Here, because the y component will be equal to sine. So 3 sine 60 degree, and that's in the direction of j, because see, this is 60, so this j component, okay, it will be cos 60 cos component, sorry, sine component, and horizontal, this will be cos component. So here we are taking y component. So this is equal to cos 60. Okay, and what is the x component? Sorry, let's resolve this into one more easy form. This is the direction of north, so I will write down J. Okay, this now it's 30 degree. This angle is 30 degree. This angle theta will be 60 degree. X component, it will be 3 cos 60. Y component, it will be 3 sin 60. This vector will be 3 cos 60 I plus 3 sin 60 j. Value of cos 60 is 1 by 2, so it's 3 by 2 I plus sin 60 root 3 by 2, 3 root 3 by 2 j. Clear? Now determine the girl's displacement. So displacement, that will be equal to A plus B. So minus 4I plus 3 by 2I plus 3 root 3 2j. So minus 4 plus 3 by 2. So that is 4 to the 8, minus 8 plus 3 minus 5 by 2 plus 3 root 3 by 2. This is displacement vector. Okay, this is displacement vector from initial point. So girl's initial displacement will girl's displacement from its initial point to departure will be minus 5 by 2I plus 3 root 3 by 2 j. Clear? So this was about question 3. So note down question 1, 2 and 3. Now let's move to the next questions. Question number 4. If A equal to B plus C, then is it true that A equal to magnitude of A equal to magnitude of B plus magnitude of C? See, if magnitude of this A is equal to B plus C, then magnitude of A will be equal to under root of magnitude of B square plus magnitude of C square plus 2 magnitude of B into magnitude of C cos theta. Okay, so see, if A is equal to B plus C, that means its magnitude will be equal to under root of B square plus C square plus 2BC cos theta. Clear? So taking square, this will be equal to B square plus C square 2BC cos theta. Clear? So now see, in this case, if angle theta is equal to 0, if theta equal to 0, that implies cos theta will be equal to 1. In that case, a square equal to b square plus c square plus 2bc. A square will be equal to b plus c whole square. In this case means when both are parallel, okay, vector A equal to B modulus of B plus modulus of C. Okay, if collinear or parallel, in that case, Okay, clear? If means if B and C, if both are parallel or sorry, if both are collinear, then this is possible. Okay, but if theta is not equal to 0, right? Let's say theta is 90 degree, right? If theta is 90 degree, b square plus c square. Example, theta is equal to 90 degree. In that case, modulus of a square will be equal to modulus of b square plus c square. In that case, this becomes a square becomes hypotenuse. Vector becomes hypotenuse, right? So in that case, it is not equal. In this case, B and C are two sides of right angle triangle. Clear? So it's not true that in every case a equal to b plus c, vector equal to vector b plus c implies magnitude of vector equal to magnitude of b plus magnitude of c. And in any other case, theta not equal to 0, like 30 degree, 40 degree, 50 degree, okay, it will never be equal to, it will never be equal like modulus of a equal to modulus of b plus modulus of c. Clear? This was about question 4. Let's see question 5th. Find the vector of x for which, let's say vector a. Here xi plus j plus k is a unit vector. That means I can multiply xi, xj, xk. Now it is given you have to find the value of x such that it is a unit vector. That means modulus of a will be equal to 1. Under root of x square plus x square plus x square, this will be equal to 1. Taking out the square root, or let's take 3x square equal to 1. Squaring on both the side, 1 square 1. So x square equal to 1 by 3. So the value of x is plus minus 1 by root 3. Okay. So this was about question number 5. So note down question 4 and 5. Now let's see the next questions. Question number 6. Find a vector of magnitude 5 units and parallel to the resultant vector of A and B. And question 7. Three vectors A, B and C are given. You have to find out unit vector parallel to vector 2A minus B plus C. Okay, so both are similar question. Clear? In sixth question, first we'll find out the unit vector, then multiply by 5. Now see, 5 units leave it. First, parallel to the resultant vector. Resultant vector of A and B means A plus B. So vector, let's say vector C will be the resultant vector A plus B. So it's 2, 3, minus 1 plus 1 minus 2, 1. Okay. So this will be equal to 2 plus 1, 3, 3 minus 2 that is 1, minus 1 plus 1 that is 0. Okay, so this is the vector, resultant vector. Okay, now we have to find out vector of 5 units parallel to this. So the vector parallel to C will be the direction. Let required vector be R. Okay, so direction of R will be equal to direction of C, because R and C are parallel. This will be equal to 310 upon under root, means I can write down that unit vector C will be equal to vector C upon magnitude of C. So this is the direction, right? So this will be equal to under root of 3 square, that is 9, plus 1 square, that is 1, plus 0. So this will be equal to 310 1 by 10. So this is the unit vector, means direction. Now the magnitude is 5 units. So the vector r will be 5 times unit vector r. Sorry, this will be 10. So this is 5 by root 10, 1, sorry, 3, 1, 0. Clear? Okay. So this was about question number 6. What we did? First we found out the parallel vector, so vector resultant vector. Then we took its direction by taking unit vector, and then we multiplied it by 5. Clear? So I can also write it down in this way. 3, sorry, see, I can make some adjustment here. It's root 10, so 5, and it's root 10, so I can cancel it. So what I can do, 5 root 10, I will write down 5 multiplied by 2 upon root 10 multiplied by 2. That will be 10 by 2 root 10. So root 10 ones are, it's root 10, so this will be root 10 by 2. This will be equal to root 10 by 2, 310. Okay, or else I can write it down 3 root 10 by 2i plus 1, that is root 10 by 2j. Okay, so this was about question 6. Now in question 7, first multiply a by 2 minus b plus multiply c by 3 and just find out this. Okay, you will get the resultant vector. Let's take this as resultant vector r. And then find out its unit vector. That will be the unit vector parallel to 2a minus b plus 3c. So question 7, I am giving it to do it by yourself. Clear? So first, note down this question number 6. Question number A. Show that points A, B and C, A that is 1 minus 2 minus 8, B 5 0 2 and C 11 3 7 are collinear, and find the ratio in which B divides AC. Okay, so first we need to find out this are collinear, so let's find out vector AB, AC and CA. Vector AB, that is B minus A, so 5 minus 1, 0 minus minus 2, minus 2 minus minus 8. This will be equal to 5 minus 1, 4, 0 plus 2, 2, minus 2 plus 8, 6. Vector BC, so that will be equal to 11 minus 5, 3 minus 0, 7 minus minus 2. 11 minus 5, that will be equal to 6. 3 minus 0, that is 3, and 7 plus 2, that is 9. CA, that will be equal to 1 minus 11 minus 2 minus 3 and minus 8 minus 7. Here, so this will be equal to 1 minus 11 minus 10 minus 2 minus 3 minus 5 minus 8 minus 7, that is minus 15. Okay, now see, if I take here AB and BC, if I rearrange this, okay, if from B I take 2 common, let's take 3 common. Okay, it will be 2 1 3 here. Now let's multiply and divide by 2. So 3 by 2, 2 2s are 4, that will be equal to 2 ones are 2, 3 2s are 6. I divide by 2 and multiply all these 3 components by 2. So now 4 to 6, that's AB. So what does this mean? This is 3 by 2 AB. I can write it down that BC is equal to 3 by 2 AB, right? Where this is in the form of BC equal to lambda AB, where lambda is scalar. So what does this imply? This implies that both are in same direction, a vector AB and vector BC, and B is common in both. So A, B and C are collinear. Okay, A, B and C are collinear. Clear? Now the second question is find the ratio in which B divides AC. So if I take ratio of AB to BC, is- here this ratio shows that B is common, so B is dividing AC. Clear? Okay, so I can see here that BC is equal to 3 by 2 AB. AB by BC, that will be equal to 2 by 3. So this implies B divides AC in the ratio 2 by 3. Clear? So this was about question number 8. So just note it down. Let's move to the next question. Question number 9. Find the position vector of a point R which divides the line joining two points P and Q whose position are 2B plus B and A minus 3B. So let's take P having position equal to 2A plus B and Q having position equal to A minus 3B. Okay, now the point R divides PQ in ratio m by n equal to 1 by 2 externally, right? Now see, this ratio is externally, so now I can write it down as the coordinates of r. Okay, now see, m by n, it will be equal to m into p, sorry, not p, m into q minus n into p upon m, sorry, plus m plus n. Here mq plus np upon m plus n. Now, as it divides externally, I will take this ratio as minus. Minus 1 by 2, or else I can take m equal to plus 1, n equal to minus 2. Right? So, coordinates of r, this will be equal to m, that is 1 into q. Q means this will be equal to a minus 3b. Minus n is minus 2, so minus 2 into 2a plus b upon m plus n, that is 1 minus 2. So a minus 3b minus 4a plus 2b upon minus 1. This will be a minus 4a minus 3a minus 3b plus 2b minus b upon minus 1. So the coordinates of r will be equal to 3a plus, sorry, there is a mistake. Here will be minus 2. Here will be minus 5. So it's 3a plus 5. This will be the coordinates of r. Okay. Now you have to show that P is the midpoint of line segment RQ. So what we'll do? Let's find out midpoint of RQ. Midpoint of RQ. That will be equal to, as it is given in the ratio 2, I can write out R plus Q by 2 because it is a midpoint. So what is R? 3A plus 5B. What is Q? That is A minus 3. 3A plus A, 4a, sorry, upon 2, plus 5b minus 3b minus 2b, sorry, plus 2b upon 2. So this will be equal to a 2a plus b, and this is equal to point P. So clearly P is midpoint of RQ. Clear? So this was about question number 9. So just note it down. Okay, students. So that's it for today. Thank you.